Hello everyone, this is the video lecture for Calculus 3, section 14.5, chain rule. So chain rule, back in the day, was something a little bit easier, I suppose you can say. Let's just do a basic one. Let's just say I have something like 2x plus 3 all to the fourth power, and they want to find the derivative. So I would take the 4, move it to the front, leave the inside alone. Now it's a third power. But we're not done because we need to take the derivative of the inside and multiply it by that right here. So ultimately my answer would be 8, because again 4 and 2 in the front make 8, and now the cube. So there you go. We're doing this now with multivariables. We can always do it this old way, but I feel that it's sometimes important to do it the long way, I guess you can call it. So let me show you, as we go through, multiple different problems where we'll be doing two different styles, I guess you could say. So I'm going to beforehand say there's two different ways to do this. First off, whenever we encounter a problem, we can just plug in and take one big derivative. I want to emphasize the big part. One very big derivative. So that's one way we can do it. That's kind of what I'm talking about. It looks kind of like this, the old way. Or we could basically do this chain rule stuff for multiple variables. So what is that going to look like? Here's the official formula. Let me get it right here. dz dt is equal to del x, it's del z del x. See, it's kind of confusing. And then dx dt plus del z del y dy dt. So let's kind of just do a zoom out of this right here. What if I were to cancel these guys and cancel these guys? You could basically see I got dz dt, dz dt, dz dt. That makes sense. So logically, that would make sense that we're in the same units. Same units. It's kind of like you cancel your feet and you have miles left over kind of thing. You have your correct units in the end. Of course, we're not going to be doing that. So one thing I have in my notes here, it says that WebAssign will want mixed answers. Mixed answers. And what I mean by mixed answers is when you're going to have T's, Y's, X's, S's, U's, V's, all kind of mixed in there. You're thinking, well, shouldn't I just get it all in one style? You can, but then it's not required. So let's basically go through some problems. I want to show you and demonstrate for you how this will work, okay? It's better through example. So first off, I got z is equal to x y to the 7th minus x squared y. Also, I have x equals t squared plus 1. And then also, I got y is equal to t squared minus 1. Now, I want to do this the old way. And then I'm going to do it the new way. So what are they wanting? Like, for all this, they're basically wanting z prime. What's z prime? Or, more specifically, dz dt equals what? Either way, I know I put old way kind of in the middle there, sorry. But the old way, what would it look like? Well, I'm going to rewrite my z, but now just with a whole lot of t's. So I'm taking this, and I'm going to plug it in. And I'm going to take this, and I'm going to plug it in. Here we go. T squared plus 1, t squared minus 1 to the 7th, t squared plus 1 squared, and then t squared minus 1. And so this is your z. Now they want z prime. And good luck with that. It is possible, but it would look so nasty. It's very large. There's nothing really to help. So I would say no, or at least ouch. It's not impossible. It's just not worth it. And that's why we're doing this new way. The new way is basically, I'm going to show you how this works. I'm going to find the derivatives kind of implicitly, and then I'm going to put in the secondary derivatives. Let me show you. Okay, so one thing before I get started, my symbols, my symbology, my notation is not the best, but it will work. So just kind of work with me. And I guess I'm going to say that because I'm going to intermix them so much, kind of like saying Z prime and DZDT, DZ, there's a whole lot of just interchange going on. So in a way, I'm just getting to the fact that it's okay to have it kind of a little bit weird, because sometimes it'll suit you to have it in one way versus another. I just want to present to you in various ways. So right now, I'm going to do ZZ. Next time I might do Z prime. I don't know. It just kind of depends. But this is still important. I'll show you as we go. So I went from Z to DZ, because I'm basically doing this implicitly. Think implicit differentiation, okay? If you can read that. And so my derivative here would be a product rule. So then I have dx times y to the 7th plus x times 7 y to the 6th dy. Moving on, minus sign. There's another product rule here. So then I have, again, 2x dx times now y. That minus sign will get also here. It's basically, I'm saying product rule with this stuff here. So that minus sign will also be on this side as well. There's not a plus sign here because it's two negatives together. I distributed, essentially. And then I got x squared, and then that's just going to be a dy. So this doesn't look any better right now, but notice that the derivative was actually kind of easy to take. That's important. You want it to be easy. So we have all this stuff here. Now what? Well, looking back at my x and my y, I'm saying now, what is dx? I'm taking this one implicitly. So then I've got, well, 2t dt. The same thing with my y. My derivative of this guy here, the 2 comes down, 2t dt. What I could do is take these directly and plug them in right there and there. Same thing with this guy. You plug it in there and over there. And so my dz is going to look kind of hideous, but I guess we'll get to it. Let me do it the straight way, and then I'll kind of show you what they're looking for an answer, okay? Y to the 7th, got an x, 7y to the 6th, dy is now a 2t dt, and then I'm going to skip down here, minus 2x times 2t dt, and then we got an x squared. Well, actually, hold on, I forgot a y. Okay. There's so many moving parts. I hope you recognize that. 2t dt. Okay, excellent. We're really close. What they were looking for in the end, though, was dz dt. Notice that the dt is in the bottom. So every time you see a dt, and it is for every term has a dt, you're going to divide it over to the other side, leaving it a little bit more simplified. Not a lot more simplified, just a tiny bit. Might as well combine like terms here. So we got 14 y to the 6th t. Keep going. Again, combine like terms if you can. Those are going to be a 4. So we got 4x t, and then a y. And then over here, we got x squared 2t. Okay. Well, that's basically your answer. You could definitely type this in and it works. Notice that it's all mixed up. T's with y's and x's. It's all over the place. And that is acceptable. You could go one step further. What they did was they said, oh, well, every term has a 2t at least. And so they factored a 2t out to the front, leaving behind y to the 7th. Here I'm taking a 2t out, leaving that 7 behind, so 7xy to the 6th. Over here, taking a 2 out, so leaving a 2xy. Taking that 2 out, leaving the x squared. It's a little better looking, but again, mixed is the key here. And they're going to do that very often. It looks wrong, but it's totally fine. There's nothing technically wrong with it. Okay. Next problem. 145005. So I've got z is equal to sine of x, cosine of y. I got x is equal to the square root of t, and I got y is equal to 6 over t. That's good enough, actually. Okay, so what you could do immediately, if you really wanted to, was do this here. And then my y would be this guy right here. And then you could just take one big derivative. It would be kind of interesting to take. You would just say z prime equals, and then just go and do it. That's not bad. You can see it's just going to be a product rule with a lot of chain rule and all that stuff. I'm not going to do it because I want to practice this other way for a little bit. So I'm not going to do this, but we could if you wanted to. Okay, that's not wrong. It's just that I'm not going to choose to go that route. So instead, let me go implicitly. dz is equal to, this is again a product rule here. So I'm going to take the derivative of the first, leaving a cosine x dx. Kind of looks like a 5 there. Leave the second one alone. Plus sign. Leave the first one alone. And then take the derivative of the cosine to make a negative sign. And then dy. Looking back at my x's and stuff, my dx, when I take a derivative here, this is technically half power. You just simply say it was half power. So the half comes down to the front, and now it's got a negative 1/2. You could simplify this a little bit to this guy. It looks pretty, but not required. The derivative here makes more sense if you were to rewrite it with a negative 1 power for that. So the negative comes down, now it's a negative 2. Again, you could simplify this by putting it as a square in the bottom. These guys are going to be plugged in there and over there. And so I'm going to skip to the dz dt. I actually technically messed up a tiny bit here. This is dt's right here. And see, the thing is, does it really matter in the end? No, but it is technically correct to do that. So dt's, and so you'll have a dt for each term. You can divide by it to the other side. Blah, blah, blah. Again, not super required, but it at least helps a little bit. X, and so then I got 1 over 2 square root of t, cosine of y, and then plus sine of x, and then I got a negative sine of y. Okay, and then times my derivative over there. Okay. Notice that 2 negatives will make a positive. You can maybe even make it look pretty, but not required. Again, mixed is okay. They are okay with that. All right. Let me show you a contrast with this next problem. 145007. This is a contrasting kind of problem. Got w is equal to x, e to the y over z. X is equal to t to the 7th. Y is equal to 5 minus t. And z is equal to 8 plus 9t. Okay. And so they're asking again, what's w prime? Or, you know how they'll probably do it. What's dw dt? Or whatever. That's fine. Either way is fine. It's just w prime. What I'm going to do is actually plug these all in right now, like the old school way. I'm going the old school method here, and that is okay. So, again, you could do this every single time. I'm just choosing to try to keep with the book. Okay, so I literally plugged it all in. We got a whole lot of t's here, and so literally now we just got a w prime. Go and solve it, dw dt. You're just taking a derivative here. And you can see that it's going to be a product rule. So let's do that. The 7 comes down, t to the 6, leave the other one alone. It's just product rule. Plus sign, leave this guy alone. What's the derivative of e to the whatever? Well, it's e to the whatever, but we're going to have a chain rule for that. So then multiply by the derivative of that power. This here is going to be quotient rule. So right here it's low d high minus high d low divided by the square of what's below. I'm doing all that right here. So here we go. Low d high is going to be a -1 minus high d low, down there's going to be a 9, all divided by the square of what's below. Phew, and that's going to be multiplied by that stuff there. Not kidding with you, this should do it. Well, I don't want to include that little formula there. There you go. That should do it. You can see that is a monster to type. Again, not always recommended, but look, I did the old school method. It wasn't a lot of confusion, so that is okay. That should work. If something like that doesn't work, you can always send it to me with the Ask My Teacher. I can look it over, check it over. It should work, though. It should. Oh, we just did a 007. Sorry. So then 011. I got z is equal to x minus y to the 7th. X is equal to s squared t, and y is equal to st squared. Notice that this is now going to have s's and t's, so it gets a little bit more interesting. Now they're basically wanting d z ds and d z dt. Notice the partials. Notice the partials on this one, because we're going to have two separate variables in the end. So we can't technically use a full derivative, but honestly, it's all the same. So what I'm going to do is I'm going to do this basically implicitly. I'm going to be a little bit more Newtonian about it. So I'm just going to kind of throw some symbols, and it should be fine. So z prime is equal to, let's do a derivative of this guy. The 7 will come down. You leave the inside alone. Now it's a 6th power. Remember chain rule. So what's the derivative of x is x prime. What's the derivative of y is y prime. So definitely just tossing around the primes everywhere. Newton would be pleased. Leibniz, not so much. And if you don't understand that, go look at history books and stuff. It's just a funny little thing there. X prime, looking right here. The 2 will come... This is a product rule, obviously. These are being multiplied. So the 2 will come down... S, and then we got a T. Now this is going to be strange. Let's just kind of pause for a little bit here. I'm going to be a little bit more Leibniz-y here. I'm going to leave it as a DS. So I have to technically do dx here instead of an x prime. I don't really know. It's not worth it. Don't go that far. Just, you're taking a derivative. Make sure you flag it, because it will be important in this particular case. Okay? So I did take a derivative with the s, and then plus, again, this is product rule here, so I'm going to now say s squared derivative of the t, it turns into a dt. So this right here is bad notation, I'll admit it, but it's not wrong in the math sense. Just go with me and we'll be okay. This one's squared, if you can barely tell there, so you're taking derivative with s, that'll leave t squared ds plus... And then you're going to take it with the t, so 2st dt. Okay. So my goal is to basically take all this here and there, plug them into those guys, and it should work out just fine. In theory. So I have now 7x minus y to the 6th, now times this whole chunk, 2st ds plus s squared dt, and then so that's one chunk minus, now the next guy, t squared ds plus 2st dt, close, close. That is one heck of a thing, and we are not done. The reason why we're not done, sorry, I'm trying to emphasize these parentheses here. The reason why we're not done is because they're asking for two different things. They're not wanting just z prime in this particular case. They want del z del s and del z del t. So it is kind of like z prime, but in turn it's a partial derivative instead of a full derivative, etc., etc. Man, that parentheses just kind of making me upset there. Anyways, we're just leaving it alone. You'll understand. So when I have this dzds, I'm going to tell you right now, little star, dt actually goes to 0. What happens is that you're taking a derivative, and a partial derivative, in terms of one variable. The other is a constant. The other one is considered a constant. Go back to whenever we were learning partial derivatives. Whenever you have, I'm just going to make something up if that's okay, 2x plus 3y. And I said, hey, I want to do the partial in terms of x, something like that. And so I would say, oh, well, this is a derivative, so 2, and then I'd have that dx, or I guess you could say just times 1 or whatever. But then what happens to this guy? He goes to 0, doesn't he? Because, again, that y is considered a constant. What's your derivative of a constant? What's your derivative of that constant? It's always 0, okay? It basically just goes away. And so I'm looking to show that. We don't even need that example. I'm looking to show that through this math. So dzds, or again, I guess you could even say like z sub s or whatever. This is forcing my dt's, wherever they are, to go to 0. And so what happens in this other color, I like to basically just cancel out anything that has a dt in it, because it's gone. That ds basically is going to come to this side over here, so you don't need those. You write everything else out, and you're done. Like, that's it. You're done. You've done your math, so now we're just kind of cleaning up the pieces here. So that would be a 2st. Again, you don't need a ds. And then on the other side, minus t squared. And that's it. We're done there. So there's your answer for the z sub s. Similarly, they want dzdt. Again, what is that? Another notation is z sub t. But what this is doing is making my ds's go to 0. So any ds's that you had up here, they go bye-bye. But your dt's, basically, are going to move over pretty much like you saw in the last case. That is a 6 power. And so left over, this is going to go away, but this is now staying. And then this is going to go away. Notice the minus sign. You got to distribute it, so therefore it's a minus 2st, and the dt already moved over. And there's your answer for that one. It seems a little weird. If you need to go back through what I just did and hear me saying it again, that's fine. If you got questions, of course, you can let me know. It's kind of like a trick more so than anything, and it's certainly not proper math. I know that a lot of folks would be screaming at me that I'm doing it wrong, my notation is incorrect. I agree, and I don't care, because I want to get it to you in a way that makes sense. Basically, I want to take my derivative implicitly, and then I'm just going to eliminate particular terms that were constants whenever I'm dealing with a partial derivative. And I did explain myself, so at least I have that. Okay, next problem. 145025. I got z equals x to the 4th plus x squared y. And they also give me x is equal to s plus 2t minus u, if we didn't have enough letters already, and y is equal to stu squared. Stew. They say in this particular one that they want to find z sub s, z sub t, and z sub u at, that's the at symbol, P equals 413. It doesn't help as much to be able to say, oh, we'll just find it at a point. It must be easier. Not necessarily. It is easier to type because you'll just have a number. So let's start getting the math done. Z prime is equal to. Again, you could just start plugging all this stuff in. I say don't. I don't recommend it. You'll get something to the fourth power. It's just a mess. So let's just do it this way. 4 x now cubed. We can say like x prime if you like, or you can say dx. It doesn't really matter in the end. Plus, I have now this other guy's product rule, so a 2xy x prime plus x squared y prime. I don't like using the primes here because see how it looks a little weird here and there? So I don't recommend doing this if you're a little confused on like the notation. Just make it dx and ignore that stuff. Make that a dx. Make that a dy. You know, all you're really doing here is you're flagging it. I'm just putting in a flag, staking it in the ground and saying, hey, I did a derivative here. Just telling you. It's maybe easier to see that way. Up to you, though. Up to you. That's what I wrote on my paper was that stuff right there. Let me erase these so I can feel better about myself, honestly. They kind of look a little gunky. Okay, good enough. Okay, now what? So we need to now find our derivatives this way. So x prime, again, dx, whatever you want to call it, doesn't really matter. We got a ds plus 2 dt minus du. Here I'm kind of more strict about the d's, but again, shouldn't really matter in the end. Y prime would be now, this is going to be a strange product rule here. What I'm going to do is I'm going to see it kind of like this. Nah, you know what? No. I'm going to see it like this. So that's my product rule. I'm going to say S times T is 1. That's like my F, and this guy is my G. So then it's F prime G plus F G prime. It's just product rule. But now it's going to get a little long. Here we go. So take the derivative of S times T. That alone is a product rule. So then I'm going to have T ds plus S dt times U squared. And then plus now for the next one, I leave this one alone, st, and then take the derivative of the t, the 2u du. All right. Woo, man. I think I did it a little differently on my paper. I don't know why I did it that way. Oh, well, that's fine. So again, you could distribute your u, and you basically get everything that you would need. You know what? Actually, I got something different over here on my notes. Yeah, where did I go wrong there? I got a T with an S. Did I mess something up? Let me just double check. Give me a second here. I did F prime G. Just leave it alone, right? And then I got F G prime. Well, maybe it's going to work itself out in the end. Maybe I just copied it wrong somewhere. I think I copied it wrong somewhere as I was going. I don't know. This is fine. It's fine. So we're going to use this, and we're going to plug that in. So this is my dy. It's going to go here. This is my dx. It'll go here and there. And we're going to get a big mess. So here we go. I got 4x cubed times ds plus 2 dt minus du, and then plus, you know what? Hold on. Notice that these both have a dx. What if I were to factor the dx out to like the back end here? That's what I'm going to try to do. So I'm going to say this guy plus 2xy. It'll be a little bit cleaner when I start doing it. So this is my dx just once. So basically, again, I'm just taking these two, factoring it to the back, I suppose. ds plus 2 dt minus du. Okay, and then this guy over here plus x squared times, and then, well, all that mess. What I'm going to do is I'm going to leave it down here, actually. Ooh, hold on. I want to make it look good. So I'm just getting room so it's easier to see. So all this stuff here. You could distribute this. I think it'll be a little easier in the end. So, real quick, let me do that guy right there. Okay, moving on. So I've got T U squared ds plus SU squared dt plus 2STU du. Whew! That is just one heck of a mess. Do you think it would have been easier the other way? No. So, z sub s at p. Really, I'm just going to find the z sub s, and then we'll plug in the p. I don't really know. Actually, yeah, let me plug in the p in just a minute. Yeah. Notice that z sub s, I'm basically then stating that dt equals 0 and du equals 0. You can basically just eliminate any terms that have that. So, like, I'm serious. Cancel, 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 and you're left with something much less. The ds gets tossed to the other side, so you're looking at something much better now. So 4x cubed plus 2xy times, well, 1 now, plus x squared times tu squared. Like, that's it. Yeah, see, I wrote it correctly the second time. Okay, we're good. Sorry, my notes didn't have a little square right here, but then I used it down here, so obviously I was using it somewhere there. So, okay, we have this guy right here. That's nice and all. I need to find out how to plug in this point that they gave me. This was an x, y, z point, I suppose. At least I'm hoping for that. So I can't really plug in a z because that's my original over there, but I can plug in an x and a y. Okay. I think at least. No, I am incorrect. Okay. I don't know why they do this. See how confusing this could be sometimes. This right here is an S, this is a T, and this is a U. Why? Why is that not an XYZ instead? I don't know. But there you go. This is going to be much easier now. Basically, I'm plugging those in for my S's and T's and stuff like that. So here's my question. What are X and Y? If I need to plug in my X and Y as well, right here, 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 there, what are those numbers going to be? I'm going to take this and I'm going to plug them into my original equations there. So really, real quick, I'm going to write on the side here, X would be equal to 4 plus 2 times 1 minus 3. So 4 plus 2 is 6, minus 3 is going to be a 3. Okay. My Y is going to be this guy here, 4 times 1 times 3 squared. So that's 9 times 4 is 36. I should then have everything. Here we go. Final answer. 4x was again just a 3 cubed plus 2 times 3 times 36 all times 1 plus 3 squared times, now what's t? 1. And what's u is a 3. 1. Oops. Let me make that a little bit better. 1. And then we said it was a 3 and then that squared. Oh my goodness. Blah, 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 blah math, and you get out of this 405, I believe. I really hope so, because that's the correct answer. Then you're supposed to repeat for the others, and it just gets a mess, honestly. What you're doing again, you're saying d sub t is what you're trying to find, and so then that's telling you that ds is equal to 0 and du is equal to 0. Go back to your original z right here and cancel those guys instead. Plug them all in, get an answer. So it's not hard as you keep going. It's just kind of repetitive. And I'm moving on, because you now know the basics. 14,5,031. So I've now got 6y cosine of x equals x squared plus y squared. And they're saying to use a particular formula on this one. So let me go ahead and give you this formula. You have to click on it. It brings you to a little link that shows the formula. It's dy dx is equal to a negative f sub x over f sub y. And they say, okay, you know what to do now. Well, one thing they're not telling you is that f must be equal to 0. So it's this stuff here, but it has to equal 0. In order for that to work, I must bring these over to one side. So let me now define what f would be. I have 6y cosine x minus x squared minus y squared now equals 0. This is my function that I will start using for the formula. And so the question is asking, what is dy dx? I know there's ways to go and find this otherwise. Strictly put, you would use implicit differentiation. This is a Calculus 1 question. It's a tough one for sure, but it is possible to do with like Calculus 1 essentially. I think so at least. It's implicit differentiation. But let's use their formula. It's not too bad, and we should be able to get something out of it. So this guy here, what's my f sub x? What's my derivative in terms of x? Well, this guy's a constant, so he just hangs out. My cosine x will now turn to a negative sine, so negative 6y sine x. This guy makes a 2x, and the y will go away. Now for my derivative of the y, my cosine's going to stay, but this now goes to just a plain old 6 cosine x. My x's go away, but that 2y sticks around. Therefore now, I take these together, just like the formula says, put a minus sign on the top, and walk away. Like that's going to be your answer here in a second. We're basically done with this problem. There you go. So they say, hey, what's dy dx? And I just say, well, that thing. You could simplify by distributing that minus sign, but it doesn't change anything. That's good enough. Okay, next problem. 145042. So they want to talk about a cone. And its height, the height of the cone is h. The radius of the cone is an r, little r. And they say dr dt is equal to a positive 1.2 inches per second. And my dh dt is equal to a negative 2.3 inches per second. And they want to know what dv dt is. Like that. When, little extra here, when r is equal to 150 inches and my h is equal to 190 inches. Phew. Let me tell you, this looks nothing like the homework problem. The homework problem is a word problem, blah, 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 blah. And it's really hard to decipher. There's key words in there that actually throw you off. It threw me off. I had to do this problem like 3 times. Because there's a word here that basically says that you're going to increase your rate of the radius or something, but yet you're going to decrease your rate for the height. Notice positive versus negative. That's what they're trying to get at. I didn't read that. I just looked at the number, and it was just a positive. It looked like a positive there. But they said the word decrease in the front. I didn't read it. The whole thing was wrong. So make sure you're looking for that stuff. How's this supposed to work? Well, you need a formula for a cone. And so my v is equal to 1/3 pi r squared h. You can definitely thank your local search engine for that one. I think I might have gotten that from Wikipedia or something, whatever. So v prime, I'm going to take my derivative of this. Notice that it's going to be a product rule. Okay, so all this 1/3 pi stuff can just hang out in the front while we talk to this stuff. 2rh dr plus, and then I'm going to have r squared dh. Basically like we have been doing. Well, we have. I know I have DT here, so I mean, if you really wanted to put a little DT underneath of these guys, that's fine. That it's the same thing. So this guy and this guy are going to be these numbers. These are going to be plugged in as well, and that's my final answer. So here we go. V prime at all these points is 1/3 pi times 2r h, and then times drdt is going to be a positive 1.2 plus r squared. R is a 150 squared. dHdt is a negative 2.3. Calculator, and basically you do, on your calculator you just don't use your pi, put all the other stuff in, and you get 5550, and then you just put your pi back in for your answer. So that's the quick way to do that. All right, that's actually the last question. So if you need something, let me know. That Ask My Teacher stuff is very important. It comes right to my email. I can go and look at it. I can get the right answers and message you back on WebAssign. Very very easy stuff. So I recommend it. Thank you very much. Have a great day. Thank you.